Hey guys, this is test 60 game 3. This is the mulch and stone game. It's a little bit unusual. I'm going to explain it. They tell us over the course of one day, meaning that there is an order in which these things occur during that day. So they tell us that, these 7 loads, the 3Ms and the 4Ss are going to be hauled. So I laid out 1 through 7. They tell us that it cannot be cleaned more than 3 times, so maximum 3 cleanings. And of course, a cleaning is when you switch from mulch to stone or from stone to mulch. Then they tell us that the 5th load must be mulch, so I put M on 5 right there. And that's really all they give you up front. Now, you might be thinking, how do I jump into the questions with just this? There is a way to set up multiple main diagrams for this game that I highly recommend. There are 4 different ways that you could lay it out based upon the placement of M, based upon the fact that M is on 5. If M's on 5, we could have, M on 4 and then S on 6, or we could have perhaps S on 4, and then M on 6, or we could have M4, M6, or we could have S4 and S6. So I'm going to create 4 different main diagrams now based upon the placements of the M's and S's around M on 5. I do this because there's this whole cleanings thing, and whenever we have, a switch from one type to another, we're going to have a cleaning. So I'm just going to give you a sense of what it looks like before I draw them in full. When we have M on 5 and S on 6, we're going to have, a cleaning between M and S. When we have S4, M5, there's no cleaning between them there. There's no cleanings between the M's because they're all the same type of load. On the bottom one with S4, S6, there's going to have to be cleanings between both 4 and 5 and 5 and 6 because we're switching from one type to another. So I'm going to draw those 4 main diagrams now. So here they are. We got M on 4, S on 6, S on 4, M on 6, M on 4, M on 6 again, and then S on 4 versus S on 6. Now, I've laid out, what happens as a result with the cleanings. We have a cleaning between 5 and 6 on top, between 4 and 5 on bottom, on the middle, second, between 3 and 4 and 6 and 7 on third, and then between 4 and 5 and 5 and 6 on the bottom one, because whenever we switch from M to S and vice versa, we have to have a cleaning. Now, I've also laid out the 3Ms and 4Ss next to each diagram so that we can see what we have remaining. In the top diagram, we used 2 M's already, therefore we have only 1 left, and we also used an S, so we got 3 S's left, etc. Now, on the third diagram, though, we already used all 3 M's, therefore the S's had to go on whatever slots were remaining. So we've used 2 cleanings on the third one, 2 cleanings on the bottom one there. Now, you could leave off here and jump right into the questions and be perfectly fine, but there are actually a number of other very significant inferences that you can make up front that are worth making if you're able to. Both of these diagrams have only 1 mulch remaining. And if we were to, think about the cleanings thing, we only have 3 cleanings, that's limited. Now, if we were to place M on 2 for either of those diagrams, we'd run into a major problem because we use up the 1 remaining mulch. Everything else would have to be a stone. We have the 3 stones left, so I'm going to just place them to show you what would happen if we were to do that. So S's are going to go into the 3 remaining empty slots, and you see what happens now is that we've got to use too many cleanings for each of these diagrams. You see, whenever we switch, of course, we end up with, a new cleaning that we have to do. So on the top diagram, we've got 1, 2, 3, 4 cleanings. On the bottom one, second one, we've also got 1, 2, 3, 4 cleanings. That's too many cleanings. We can only have a maximum of 3, meaning only 3 switches between mulch and stone. Therefore, since this was caused by M on 2, remember, we can't actually have M on 2 in either of these diagrams. We have to have M on 1. So I'm going to put that down. We have to have M, not necessarily on 1, but we can't have M on 2 because of what happens as a result. Instead, we're going to have S on 2 for both of these diagrams since M could not be there. And then we have, of course, we also have to avoid that whole switching thing. And if we were to put M on 3 here, we'd run into the same problem. We'd have cleanings on either side of it, and then we'd also have a cleaning between this and the S's that result, talking about 6 and 7 here. So for that reason, we can't have M on 3 in this particular diagram either. We have to have S there. Aside from that, though, we could have M and S interchangeable on this second diagram. We could have M or S on 1 and have the other one of those 2 on 7. That would be perfectly fine. Either way, since we only used 1 cleaning here, having another cleaning wouldn't be the end of the world. We wouldn't still reach our maximum of 3. So we'd be perfectly fine there. With regard to this top diagram, though, we can actually flesh it out a lot more, even though it might not seem that way at first glance. Because we have only one m remaining, and that m can go to any of 1, 3, or 7, we can make 3 different diagrams within this one representing the various placements of m. We could have m on 1, m on 3, m on 7, and use that as our wedge to create these diagrams. So if we have m on 1, then we're going to have s on 3 and s on 7. If we have m on 2 versus m on 3, then we have s basically in whatever spaces remain, since s is incredibly limited. So that's what happens with the top diagram. The second one, the bottom diagram, turns out is actually pretty interesting. Now remember that in the bottom diagram we already have 2 cleanings, so there's only 1 cleaning left for us to put down. Now we still have 2 m's and 2 s's left to put down. If we were to put m on either 3 or 7, we would end up having too many cleanings, because we'd have to have another changeover in the other spot. So if we put m on 3 and had a changeover here, we would need to have a changeover between wherever else m and s would have to touch. As such, we would have to have 4 cleanings total. So the bottom this diagram right here can't have m on either 3 or 7, so we have to have s on both of those spots, and then our 2 m's will go on 1 and 2, so cleaning here, and then no cleaning anywhere else, so we're totally good. And these right here are our 4 different main diagrams for the game. The top diagram has 3 possibilities, the second diagram has 2, and then these 2 bottom ones are only limited to 1 possibility each. So you see there's actually only 7 possible solutions for the game. This game is actually very limited, and you'll see that as we move through the questions, having these 4 diagrams makes it relatively easy to solve. So they're asking us, for question number 13, what's a pair of loads that could both be mulch? We'll just run through our choices here for each one. Could we have m on both 1 and 3? On the top diagram we have m on either 1 or 3 depending on which one we're looking at, but never both. We have m on 1 maybe, we have m on 1 and 2, but never 1 and 3, so A is gone. Next, looking at B, could we ever have m on 2 and 3? No m on 3 only, no m's at all on 2 and 3, m on 2 only, therefore B is gone for 13. Looking at C, m on 2 and 6, m's not on 2 in any of these, and then in the bottom diagram where we do have m on 2, we have s on 6, therefore C is not possible either. Looking at D, m on 3 and 6, m is on 3 here, but s is on 6 there. M is not on 3 in any of the others, therefore D is impossible, leaving E by elimination. And if you look at it, M could happen on 4 and 6 in this diagram right here, where M is on 4, 5, and 6, so E works for 13. Next, number 14, what must be true? We'll just run through our choices here. Must we have S on 2? No, in the bottom diagram we had M on 2, therefore A is gone. Must the first and second loads be the same type of material? Happens here, but we could have M on 1, S on 2 in either of the top 2 diagrams, therefore B is not a must either. 2 and 3 being different, no, they could easily be the same in the third diagram and the second one, even in the first that could happen, so C is not a must either. Looking at D, do we have to always have at least 2 mulches consecutive, meaning touching? We have that here, we have that here, we have that, here we have 3 of them touching, and then 2 of them touching there. So yes, that always happens in every single diagram. Therefore, it's a must, and D is our answer for 14. I will look at E, though. 3 occurring consecutively didn't happen in the bottom. Could happen in some other diagrams, but does never happen in the bottom one. Therefore, it's not a must either. E is gone, leaving D. Next, number 15. If the third load was mulch. That never happens in diagrams 2, 3, or 4. Therefore, those are all irrelevant. We're only looking at the top one here, where M is specifically on 3, so I'm going to cross off all those other possibilities. And of course, what results is that S is on 1 and S is on 7. So what must be true? S on 1 choice E, we had it right there, therefore we're good for 15. I will look at the rest, though. 6 and 7 being different doesn't happen. They're actually the same. First and second being different, no, they're the same as well. They're both S. 7 being mulch, no, it's stone. And then 6 being mulch, no, it's stone, also leaving E. Next, number 16, if we had exactly 2 cleanings. So in the bottom diagram, we have to have 3, so the bottom one's irrelevant. In the second and third ones, we have exactly 2 cleanings. Third, it's very obvious we have 2 cleanings right there. In the second, we have 1 cleaning here, and then we'll have another cleaning either between 1, 2, or between 6, 7, depending upon where M and S go. And then in the top diagram here, we could have 2 cleanings depending on where M goes between 1, 3, and 7, so that could work too. What must be true, as you see, in the remaining diagrams, we have S on 2 in every single one. Therefore, we know that's a must, and A is our answer. I will look at the rest, though. Third being Mulch. No, we have stones here, so B's gone. Next see third B stone. No, we have a Mulch as a possibility right there, so C's gone. 6 being Mulch. No, we could have stone right there, so D's gone. And then E7 being Mulch. No, we have stone here just as one example, so E's gone, leaving A. Next, number 17, if we had no more than 2 loads consecutive, meaning if we never had 3 or maybe even 4 things consecutive of the same type, what could be true? So obviously we're getting rid of this third diagram where we have 3 things consecutive. We're getting rid of the second diagram where we have 3 S's consecutive. And then the possibility where we have 3 M's in a row or 3 S's in a row, those are also out. So therefore I'm getting rid of the middle possibility with M on 3 in the top diagram. And I'm also getting rid of the bottom possibility of the top diagram where we have 3 S's consecutive. So we're looking specifically where M is on 1, because then we have M, S, S, M, M, S, S. So no 3 loads consecutive, so we're good. The top diagram and the bottom diagram are what's relevant here. And they're asking us what could be true. So could the first load be stone? No, they're both Mulch in the top and bottom diagrams, so A is gone. Could the fourth load be stone? Yeah, we have that right here in the bottom diagram. Therefore, we're good for B for 17. I will look at the rest, though. Third being Mulch. No, it's stone in both of those, so C is gone. Sixth load being Mulch. No, we have stone for both of those, so D's gone. And then E7 being Mulch. No, we actually crossed off, the possibility where M was on 7. We were limited specifically to where M's on 1. So E's good for 7. So E's gone for 17, leaving B.